their graph, and hopefully you've watched the lesson on graphing quadratic functions. Quadratic functions are something that's called a parabola. It's the shape of their graph. And the really cool thing about a parabola is there's always this point called the vertex. Now, if our parabola opens upward, we have a minimum value. So when we have a quadratic function, we're able to minimize things like costs and losses and things like that. We're able to find out how to minimize those for business equations and things like that. Okay? The other option for a parabola is it could open downward. And again, that vertex has special significance because when it opens downward, that vertex is a maximum. Okay? So we're able to maximize profits. We're able to maximize the area of a figure. Okay? So that's why we care so much about the applications of quadratic functions, because it is very useful to us in so many different areas. Now remember that maximum or minimum point is called the vertex, okay? And for a quadratic function written in this form, which it typically is when we talk about applications, f of x equals ax squared plus bx plus c, in order to find that vertex that's so valuable to us, we use the following formula. The x-coordinate is negative b over 2 times a. Okay, and notice here's our a and here's our b in our quadratic function. Those are just numbers when we get to an actual problem. Okay, so don't be concerned. The y value of our vertex, we just plug that back in, so it would be f of negative b over 2a. Whatever you get for the x-coordinate, you just plug it back into your function to find. Okay? So this is our x for maximizing or minimizing, and this is our y, or our result. So let's talk about a few applications. Here's one. Find two positive real numbers whose product is a maximum. Okay? So we know we're going to be dealing with a quadratic function at some point. And where the sum of the first and 2 times the second is 36. Now I'm going to conveniently, since I've done these types of problems before, I'm going to conveniently call my two numbers x and y. Okay, so when we're doing this, our f of x, okay, is the product. Okay, and the reason I know it's I wanted to do that, and what the function, it's going to be a maximum. The product means to multiply the two. Well, that doesn't do us any good because we have multiple variables. We have an x and we have a y. We need to be able to remove one of those, and the way that we do that typically is by substituting for something else, which is why they gave us this second set of information. Okay? They told us that the sum of the first and 2 times the second is 36. Now again, having done this before, I can tell you it comes out much more cleanly if I make the first one y and the second one x in this case. Okay? Sum means to add. So here's my other equation. I know that the first one, y, plus 2 times the second one, x, is equal to 36. In order to substitute, I need to solve for one of those two. It's easier to solve for y because we won't have any division involved. So I'm going to subtract 2x from both sides to isolate the y. And I find that y is equal to 36 minus 2x. Now, my whole goal there was so that I could remove one of the variables from this function over here. I'm going to do that because I know that y is the same thing as 36 minus 2x. So I'm able to take 36 minus 2x. It's the same thing as y, so I can put it right where the y is in this equation. So now I have f of x is equal to x times my y, which I know is 36 minus 2x. I'm just substituting something it's equal to. I'm going to go ahead and distribute my x. X times x, whoa, that's a 36 typo to make. 36 times x is 36x, and x times x is x squared. Now again, we talked about a maximum here, and we talked about how quadratic functions have either a maximum or a minimum. So we want to make this look like a typical quadratic function. Usually we put the higher exponent first, so we're just going to kind of switch those around and have negative 2x squared plus 36x, because that's the way we're used to looking at it. Now, to find our vertex, which we want because that's our maximum value, we know we will have a maximum because our a, our front number, is negative. Okay, here is our a, here is our b. We do not have a c in this case, but we don't need it for vertex anyways. So to find our vertex, or our maximum, we do negative b over 2a. In this case, that would be negative 36 over 2 times negative 2 for our a. Gives us negative 36 divided by negative 4, and then all we have to do is find 36 divided by 4. So the x value of our vertex is 9. So I know that x is equal to 9 will be the maximum here. Well, what is y going to be, you might ask? Well, we happen to know from our original problem that y is 36 minus 2 times x. So I go back and substitute again to find my other variable. Now that I know x is 9, I can just plug it right in there, and I get 36 minus 18, or 18. Okay, so the solution to this problem is that one of my numbers is 9, the other is 18. Okay, so again, what you do is you start out with your function being a product of two numbers. You then use the second part of the problem to set up a second equation. Y plus 2x is 36. I solved for one variable to isolate it, and then substituted back in so that I could have only one variable in my problem. I rewrote the quadratic so that it looks the way we were used to seeing it. Okay, and then found the vertex, or at least the x-coordinate of the vertex is what I needed there. I found that x was 9 when I was at my maximum, and I substituted that back in to find the value for y, which happened to be 18. Okay, these are a little tricky at first. After you do a few, they don't get to be quite so bad. This is a similar problem. What's the largest rectangular area that can be enclosed with 32 inches of string? All right, well, let's draw a picture of a rectangle, if I can. Okay, they haven't told us much about the rectangle, except for that we want to use 32 inches of string. Now remember, that would be the distance around the figure, and if you remember from geometry, that was our perimeter. We know that rectangles have length and width, and their perimeter is 2 lengths plus 2 widths, so 2L plus 2W, correct? We also know that the perimeter for this needs to be 32, because that's how many inches of string we want to have. We are trying to find the largest, so a maximum area. So then we say, okay, we're trying to maximize area. So what is the formula for area of a rectangle? Length times width. Now notice we have a very simple problem to that last one we just did. We have two equations. Area is length times width. This is the one we want to maximize, okay? And over here we have kind of a seed equation that 32 is 2 times the length plus 2 times the width. We found that because our perimeter is 32, and the formula for perimeter of a rectangle is 2L plus 2W. We want to do the same thing. We cannot maximize our area when we have two different variables. So we want to solve for either L or W in our second equation over here with the perimeter, and substitute it into our equation for area. So let's choose, doesn't matter what you want to do, either L or W to solve for. Let's say I chose to solve for W. So I subtract 2L from both sides. Okay, and then I still have a 2 there, so I'm going to have to divide everything by 2. Make sure you divide everything by 2. 32 divided by 2 is 16, and 2 divided by 2 is negative 1L. So now I know that my width is equal to 16 minus the length. And what I'm going to do with that is take it up here. Since I know W is the same as 16 minus L, I can replace my W with 16 minus L. Right? Next order of business is to distribute the L using multiplication, and I get 16L minus L squared. Notice this is now quadratic because I have an L squared and an L. I'm going to just kind of rewrite it so that's the way we're used to seeing it. Okay, put the squared first and the other second. I know I'm going to have a maximum because of the negative here tells me this parabola would open down and would have a maximum point, which is awesome because that's what we were trying to do, is find the largest area. And now we go ahead and find the vertex because that is where our maximum is at the vertex. We want the first coordinate, which remember we do negative b over 2 times a. A is the number in front of L squared, b is the number in front of L. So we have negative of negative 16 over 2 times negative 1. Excuse me, I'm so sorry. Anytime you see an error in these, if you email it to me, I'll give you extra credit. It's a little late tonight. Sorry. Notice, please, that I made a typo right there when I switched my values. It should have been a plus 16. This would be negative 16 over 2 times negative 1. Gives me 16 over negative 2. Or positive 8. Okay? So I know that when I have a maximum, my length is going to be 8. I need to go back and find my width. So I use my formula I had for width that I substituted in, and I get that the width is 16 minus the length. I know that my length is 8. Okay? So my width is also, well, 16 minus 8 gives me 8. And this happens every single time. The maximum area you can get from a specific rectangle is if it's a square. Okay, if you have to have a specific distance around it, the largest area is going to come if you have a square. My length is 8, my width is 8. What did the question ask for? What is the largest rectangular area? So we go ahead and find the area. If our length is 8 and our width is 8, our area is 64. Okay? So that would be our answer.